Whenever you have an industrial era, it's typically because a general purpose technology like electricity or digital communications, the cost of using those things goes down to a point where you don't really worry too much about how much they cost. Right? I'm not worried about the cost of the lighting in this room right now. The cost of intelligence, powerful, capable intelligence, will head down towards zero. It won't get to zero. You have digital employees, essentially, that will work for the cost of electrons. They'll work for electrons, not dollars and cents. And that changes the equation.
Let's quantify what working for electrons actually means. A senior developer in San Francisco costs $300,000 annually. That's $25,000 per month, or roughly $1,200 per day. GPT-4 or 5 or 6 doing equivalent work, it's about $20 a day in API costs. That's not a 10x improvement, that's a 60x improvement. But here's what Steve understands that most miss. This isn't about replacing developers. When electricity became cheap, we didn't use less electricity. We found 1,000 new ways to use it. The same is happening with intelligence. The real question isn't how many developers can we cut, it's what becomes possible when intelligence is essentially free.
There's that old adage, if you could make your programmers, your development team, 10 times more efficient, will you fire 90% of your development team, or will you write 10 times as much code? You know, I think if you are a software company and you're innovating, you're going to develop 10 times as much code. The output will be much greater and probably higher quality. AI is also good for documenting the code that you write and for debugging the code you write. So there's just going to be this collaboration between human and machine.
Steve framing reveals the strategic choice every company faces. Most likely the companies that thrive won't be those using AI to do the same things cheaper. They'll be those who use it to do things that were previously impossible.
The smart companies are going to meld bought code and built code. Because often you buy stuff in because there's no point reinventing the wheel. Same way you use a code library, right? If someone's already optimized a particular piece of code, why would you rewrite it? It's just, pull it in as a library and use it. The same is true here. If there's a foundational model that works really well through application, it gives you the response you need, the price is right, someone else is there to sustain and maintain it, add value around that. It'll be about time to market, and then a trade-off between how much maintenance and sustainment do I want to do, and where can I get the best impact with the coding team that I have.
Steve traces programming's evolution from hexadecimal to Python, each abstraction layer trading some performance for massive productivity gains. AI represents the next leap, from syntax to intent. Consider this, a typical SaaS feature that took 3 sprints, 6 weeks, 4 developers, $60,000 in salary costs. Well, it can now be prototyped in, say, 3 days by one developer using AI assistance. And that's not just faster, it's a different economic equation entirely. The constraint shifts from, can our team build this, to, is this worth building? When a feature costs $2,000 instead of $60,000, you can afford to experiment with ideas that were previously too expensive to explore.
I'm old enough to have programmed in BASIC, Pascal, C++, and watched the history of programming over time. When I was younger and had a good head of hair, one of the ways you got the most out of the really crappy hardware that you had at the time was that there'd be particular tight code loops that you would program in assembler. So you'd have to get right down to the instruction level to get the most out of things. And sometimes that meant typing in hexadecimal code, right? And then you could abstract away from that with assembler language. Then you could abstract away from that if you were willing to go a bit slower with interpreted languages like BASIC, then compiled languages like C++. I think what we're talking about with AI is just another layer of abstraction, where instead of having to really understand how to get the best out of that particular coding language, I just have, as a developer, to know how to solve problems using software. So it's a slightly different and expanded skill set. You see HR and IT coming closer together. Moderna, they were the first company to say, we've now got a combined IT and CHR, so CIO and CHRO have combined, because we realize we now preside over a part human and part digital workforce. Instead of building a database, right, you'll be building a digital employee, an agent that has certain characteristics and basically a job spec. So, having the ability to define as part of a role in a broader team, what is this piece of technology going to do? How are they going to behave? How will they interact with other people?
Companies treating AI as an IT initiative will lose to those treating it as a fundamental economic shift. Steve's insight about HR and IT merging isn't organizational theory. It's a recognition that managing intelligence, whether human or artificial, is now the core competency. The electron economy doesn't wait for strategic planning cycles. Steve Brown's electron economy isn't a prediction. It's already here. Every day you delay adopting this mindset, your cost structure becomes less competitive. The shift from dollars to electrons isn't just about cheaper development. It's about reimagining what software can be. When a digital employee costs less than your monthly coffee budget, when experiments cost hundreds instead of hundreds of thousands, when time to market drops from months to days, every assumption about software economics breaks.